The world around us is a tapestry woven from countless hidden processes, a symphony of industry playing out behind closed doors. We touch, wear, and use products every single day, yet rarely do we glimpse the intricate journey they undertake from raw material to finished form. What if you could step beyond the curtain, past the guarded gates, and into the heart of a manufacturing marvel? What if you could witness the transformation, the alchemy, that turns a simple, natural fiber into the warmth and comfort we cherish? Imagine a landscape, vast and open, where nature's bounty thrives. From this serene origin, a fundamental material is born, destined for a journey of remarkable complexity. It's a material that has clothed humanity for millennia, evolving from ancient craft to a pinnacle of modern industrial precision. But how does it truly happen? How does the raw, unrefined essence of nature become the sophisticated fabric that defines comfort and style across the globe? This isn't just about production. It's about an ancient secret, perfected by cutting-edge technology, unfolding before your eyes. Prepare to embark on an extraordinary expedition. We are about to enter a realm where tradition meets innovation, where the softest fibers are tamed by powerful machines, and where every thread tells a story of meticulous engineering. This is a world of colossal scale and microscopic detail, a place where the very air hums with the rhythm of creation. Forget what you think you know about everyday products. We are about to pull back the veil on one of the most enduring and essential industries, revealing the hidden world behind the wool products that warm our lives. This is the factory floor, a stage for transformation, where the ordinary becomes extraordinary, step by precise step. Wool. It's more than just a fiber. It's a marvel of natural engineering, a testament to evolution's genius, refined over millions of years to protect its wearer from the harshest elements. For thousands of years, humanity has harnessed its unique properties. But how much do we truly understand about this ancient material? Did you know that a single strand of wool is incredibly complex, composed of an outer layer of overlapping scales, much like roof tiles? These scales, made of keratin, are responsible for wool's remarkable ability to shed water, making it naturally water-resistant. But they also play a crucial role in its felting properties, a characteristic that has been both a blessing and a challenge for manufacturers throughout history, leading to both desired outcomes like felted hats and undesired ones like shrunken sweaters. Consider its unparalleled elasticity and resilience. Wool fibers can be stretched up to 30% of their length when wet and still return to their original shape, a feat few other natural or synthetic fibers can match. This incredible resilience is why wool garments resist wrinkles, maintain their form, and drape beautifully, even after repeated wear and packing. It's a natural spring, built into every microscopic coil and crimp of the fiber. And what about its legendary warmth? It's not just the thickness of the fabric. Wool fibers are naturally crimped, creating millions of tiny air pockets within the yarn and fabric structure that trap body heat, acting as an exceptional insulator. This inherent crimp also gives wool its characteristic bulk, softness, and loft, making it incredibly comfortable and luxurious against the skin, far surpassing many synthetic alternatives in tactile appeal. The history of wool is as rich and textured as the fabric itself, deeply intertwined with the development of human civilization. Evidence suggests that humans began domesticating sheep for their wool as far back as 10,000 BCE in Mesopotamia, marking a pivotal shift in human resourcefulness. The earliest known woven wool textiles date back to Mesopotamia around 4000 BCE, showcasing early mastery of spinning and weaving. The Romans were pioneers in large-scale wool production, establishing sophisticated fulling mills and developing advanced dyeing techniques that allowed for a wider range of colors and finishes. Fast forward to the Middle Ages, and wool became the undisputed backbone of European economies, particularly in England, where it was famously said that the country rode on the back of the sheep. The immense wealth generated by the wool trade funded cathedrals, fueled empires, and shaped political landscapes for centuries, demonstrating its profound economic and cultural impact. But the journey of wool hasn't been without its fascinating twists and turns, its periods of innovation and stagnation. For centuries, the process of transforming raw fleece into yarn was a laborious, manual task, requiring immense skill and time. The invention of the spinning wheel in the 14th century dramatically increased efficiency, and later, the power loom during the Industrial Revolution revolutionized production, making wool textiles accessible to the masses and fundamentally altering the textile landscape. Yet, even with these monumental advancements, the core challenge remained: how to consistently and efficiently process a natural fiber with such varied characteristics, from coarse carpet wools to superfine apparel wools. Modern innovations have tackled this head-on, from advanced scouring techniques that remove impurities without damaging the delicate fibers, to sophisticated carding and combing machines that align them perfectly, minimizing breakage and maximizing yield. Think about the incredible diversity of wool itself, a spectrum of textures and properties tailored by nature and selective breeding. Merino wool, renowned for its superfine fibers, comes from sheep specifically bred for their soft, non-itchy fleece, making it ideal for next-to-skin garments, luxury suiting, and performance activewear. In contrast, coarser wools from breeds like Romney or Lincoln are prized for their durability, strength, and bulk, perfect for robust carpets, durable outerwear, and upholstery. Each type presents its own unique processing requirements, a testament to the specialized knowledge and adaptable machinery required in this intricate industry. Did you know that some high-yielding sheep breeds can produce up to 15 kilograms of wool per year? That's enough raw material to make several high-quality sweaters or a substantial blanket, highlighting the incredible productivity of these animals. Beyond its warmth and durability, wool possesses another remarkable quality: its exceptional breathability and moisture management. Unlike many synthetic fibers that can trap moisture against the skin, wool can absorb up to 35% of its weight in moisture vapor without feeling damp to the touch. It then releases this moisture slowly, a process known as sorption, which helps to regulate body temperature. This makes wool an ideal material for activewear, keeping you warm when it's cold and surprisingly cool when it's warm by facilitating evaporative cooling. It's a natural climate control system, intricately woven into the very fabric of the fiber. Furthermore, wool is naturally odor-resistant, thanks to its complex chemical structure which traps odor-causing bacteria, making it a favorite for garments worn during extended periods without washing. And what about its sustainability credentials? Increasingly vital in today's environmentally conscious world, wool is a truly renewable resource, growing naturally on sheep year after year, powered by grass, water, and sunshine. It's also completely biodegradable, returning its nutrients to the earth at the end of its long life cycle, unlike many synthetic alternatives derived from finite fossil fuels. Compare this to the environmental footprint of petroleum-based textiles, and wool's ecological advantages become even more compelling. Modern wool production also focuses heavily on animal welfare, responsible land management, and minimizing water and energy consumption, ensuring a sustainable future for this ancient and vital industry. Certifications like Responsible Wool Standard, RWS, are becoming increasingly common, assuring consumers of ethical and environmentally sound practices. The sheer scale of global wool production is staggering, a testament to its enduring demand. Millions of tons of raw wool are processed annually, contributing significantly to economies worldwide. Australia, New Zealand, and China are among the largest producers, each with specialized breeds and sophisticated processing techniques that cater to diverse market needs. The journey from a sheep's back in the vast plains of Australia to a designer suit in a European boutique involves a complex global supply chain, a meticulously choreographed dance of logistics, trade, and precision that few ever consider in their daily lives. This global network supports countless jobs and drives innovation across continents. Have you ever wondered why some wool feels delightfully soft and luxurious, while others might cause that familiar, irritating itch? It often comes down to fiber diameter, a critical metric measured in microns. The finer the fiber, the softer it feels against the skin. Merino wool, for instance, typically boasts fibers less than 24 microns, with superfine varieties dipping below 17 microns, making them incredibly soft and non-irritating. In contrast, coarser wools can be 30 microns or more. Our skin's nerve endings can detect fibers over a certain diameter, triggering that familiar itch sensation. This scientific understanding has driven breeders and manufacturers to develop wools that are increasingly fine and comfortable, pushing the boundaries of what's possible with a natural fiber, leading to innovations like next-to-skin merino base layers. The innovations continue at a rapid pace, ensuring wool's relevance in the 21st century. Scientists and textile engineers are constantly exploring new ways to enhance wool's natural properties, making it even more versatile and high-performing. This includes developing machine-washable wools through specialized polymer treatments that smooth down those microscopic scales, preventing felting during agitation. Other advancements include creating flame-resistant wools for protective gear, developing wool blends with other fibers for enhanced performance, and pioneering new dyeing techniques that reduce water and chemical usage. The future of wool is not just about honoring tradition, it's about pushing the boundaries of textile science, ensuring this ancient fiber remains a leading material in a rapidly changing world. It's a story of continuous discovery, where every thread holds a secret waiting to be unraveled by human ingenuity. The journey of wool from fleece to fabric is a meticulously orchestrated industrial ballet, a symphony of precision and power, beginning long before the raw material even reaches the factory gates. It starts with the sheep, typically shorn once a year, a process that requires skilled shearers to remove the entire fleece in one piece, minimizing cuts and maximizing the value of the wool. The raw fleece, known as greasy wool, is then carefully skirted and sorted. This initial sorting, often done by hand by experienced graders, separates different qualities of wool based on fiber length, fineness, color, and strength, as well as removing obvious impurities like vegetable matter, burrs, seeds, and heavily soiled sections. This is a critical first step, as the quality and consistency of the raw material dictate the characteristics and ultimate value of the final product. Upon arrival at the manufacturing facility, often arriving in massive bales weighing hundreds of kilograms, the greasy wool undergoes its first major transformation, scouring. This is a sophisticated, multi-stage washing process designed to remove lanolin, the natural grease, dirt, sweat, suant, dried perspiration, and other contaminants that can account for up to 50% of the raw fleece's weight. The wool is fed into a series of large, interconnected washing bowls, each containing warm water and carefully formulated mild detergents. Conveyor belts with rakes or plungers gently move the wool through these baths, ensuring thorough cleaning without harsh agitation that could damage the delicate fibers or cause felting. The water is often recycled and treated in advanced filtration systems, reflecting modern environmental standards and minimizing water consumption. After scouring, the wool is thoroughly rinsed in clean water and then dried in large, temperature-controlled ovens, emerging as clean, fluffy white fiber, ready for the next stages. Next comes carding, a crucial process that disentangles the wool fibers, opens up any remaining clumps, and aligns them into a continuous web. The clean, dried wool is fed into a carding machine, a massive apparatus featuring large rotating cylinders covered with thousands of fine wire teeth. As the wool passes between these rapidly rotating cylinders, the teeth gently pull the fibers apart, individualizing them, removing any remaining short fibers or fine impurities, and arranging them roughly parallel to each other. This creates a soft, uniform web or lap of wool, which is then condensed into a thick, rope-like strand called a sliver. For some finer wools, particularly those destined for worsted yarns, known for their smoothness and strength, an additional step called combing might follow. Combing further refines the sliver by removing even shorter fibers, noils, and aligning the remaining long fibers even more precisely, resulting in a smoother, stronger, and more lustrous yarn. From the sliver, the wool moves to the spinning stage, where the transformation into yarn truly takes shape. Here, the sliver is drawn out and twisted to create yarn of the desired thickness and strength. This process, known as drafting and twisting, is performed by sophisticated spinning frames, such as ring spinning or open-end spinning machines. The sliver is attenuated, or stretched, through a series of rollers to the desired linear density, and then rapidly twisted by a spindle or rotor to impart strength, cohesion, and durability to the individual fibers, locking them together. The amount of twist is meticulously controlled and determines the yarn's characteristics. A higher twist creates a stronger, smoother, and more compact yarn, while a lower twist results in a softer, bulkier, and more lofty yarn. Automation plays a significant role here, with sophisticated sensors monitoring yarn tension, thickness, and breakage, ensuring consistency and maximizing production efficiency. Once spun, the yarn may undergo further processing depending on its intended use. It might be plied, where two or more single strands of yarn are twisted together to create a stronger, more durable, or visually interesting multi-ply yarn. This is common for knitting yarns, carpet yarns, or those used in heavy-duty fabrics where extra strength is required. Dyeing can occur at various stages to achieve specific color effects, as raw fiber before carding, stock dyeing, as sliver, top dyeing, as yarn, package dyeing or skein dyeing, or even after the fabric is woven, piece dyeing. Large, pressurized vats or continuous dyeing ranges are used, often controlled by advanced computer systems to ensure precise color matching, consistency across batches, and efficient use of dyes and chemicals. Post-dyeing, the yarn is dried and wound onto cones or bobbins, ready for the next stage. Weaving or knitting is the next major step, where the yarn is transformed into fabric. For woven fabrics, the yarn is loaded onto massive, high-speed looms. Warp yarns, running lengthwise, are meticulously threaded through the loom, and weft yarns, running crosswise, are interlaced over and under them in various patterns, plain, twill, satin, to create the desired fabric structure. Modern looms are highly automated, capable of producing vast quantities of fabric with intricate patterns at incredible speeds, often monitored by optical sensors for defects. For knitted fabrics, knitting machines use thousands of needles to create interlocking loops of yarn, forming a flexible, elastic fabric. Robotics are increasingly integrated into these processes, handling tasks like yarn loading, automatic knot tying, and real-time defect detection, minimizing human intervention and maximizing output. After weaving or knitting, the fabric undergoes a series of critical finishing processes to enhance its appearance, feel, and performance. These can include fulling or milling, where the fabric is deliberately shrunk and felted through controlled moisture, heat, and mechanical action to create a denser, more compact, and softer material, often seen in Melton or felted wools. Other processes include napping, where wire brushes raise fibers to create a soft, fuzzy surface, like flannel, shearing, to trim the surface fibers to a uniform height for a smooth finish, and various chemical treatments to impart specific properties like water repellency, wrinkle resistance, moth-proofing, or anti-pilling characteristics. Quality control is paramount at every stage. Automated optical inspection systems scan the fabric for flaws, while highly trained human inspectors perform tactile checks for texture, hand feel, and overall aesthetic quality, ensuring every meter meets stringent standards. Finally, the finished fabric is prepared for distribution or further manufacturing. It might be rolled onto large bolts for sale to garment manufacturers, or it might proceed to an in-house cutting and sewing department. This often involves precision cutting machines, sometimes laser-guided or CNC-controlled, to cut fabric pieces with minimal waste. Automated sewing lines then assemble these pieces into final products, whether it's a garment, blanket, carpet, or upholstery item. Sophisticated packaging equipment then prepares the finished goods for shipment. Throughout the entire factory, safety protocols are rigorously enforced, from machine guarding and emergency stop systems to advanced air filtration and noise reduction, ensuring a secure and healthy environment for the workforce. The intricate logistics of moving raw materials, work in progress, and finished goods are managed by an intricate network of conveyors, automated guided vehicles, AGVs, and sophisticated inventory management systems, all working in concert to deliver the warmth, comfort, and enduring quality of wool to consumers worldwide, a testament to industrial ingenuity. From the vast, open fields where sheep graze to the intricate dance of machinery on the factory floor, the journey of wool is a testament to both nature's ingenuity and human innovation. We've seen how a simple fiber is transformed through a complex series of steps, each one critical to creating the durable, comfortable, and versatile products we rely on. The sheer resilience of wool, its ability to regulate temperature, its natural breathability, and its sustainable nature are truly remarkable. making it a material that has stood the test of time and continues to evolve, adapting to modern demands while retaining its timeless appeal. But what other everyday materials hold such fascinating secrets? What hidden worlds exist behind the products that shape our lives in unexpected ways, transforming humble ingredients into delightful creations? If you found the intricate transformation of wool intriguing, imagine the journey of an exotic fruit, cultivated in distant lands, processed with high-tech precision, and turned into a delightful, sugary treat. The world of food manufacturing is just as complex and captivating as textiles. Join us next time as we step inside a high-tech starfruit factory, watching exotic carambola become candy, step by step. That video just appeared on your screen. Click on it now to continue your journey into the hidden world of manufacturing. Don't forget to subscribe to our channel for more incredible insights into how the world around us is made, and tell us in the comments below, what was the most surprising fact you learned about wool today, or what other natural fiber would you like us to explore next? Your curiosity fuels our next adventure.